Welcome to the video on net and total distance. I guess I should specify that's with a velocity function, and it's just, well, I'll explain. So net distance, if you want to find the net distance someone travels during a certain time interval, you just take the integral. And it should make a little sense, because, actually I'll explain it. So, let's say we have a v versus t graph. So we've got t on this axis and v on this axis, right? So let's say we have a function like that, and we want to find the integral from 2 to, let's just say it's 2 to 6. I guess it could just be a to b. But it's roughly this kind of rectangle right here, right? Well, how do we know that that tells us distance? What's our equation for distance? Distance equals velocity times time. Oh wait, velocity times time, that's just the area of that rectangle. So that's why this integral works. That's how we can find the net and total distance. So now I'm actually going to do an example, and we'll see how it goes. So let's do the integral from 0 to, and I'm making this one up on the fly, so you never know. 0 to 3 pi over 2 of cosine of x dx. So first we want to find net distance, and then I'll also explain total distance. So the net distance is just the integral. So first thing we do is we say u equals, well, we don't need to do u substitution for this, obviously. So what is the integral of cosine? That is just sine of x. So now we plug them in. We plug in sine of 3 pi over 2 is down here, so that's -1 minus sine of 0 is 0 equals -1. So the integral from 0 to 3 pi over 2 of cosine of x dx equals -1. Now let's do the total distance. So with the graph of cosine of x, it starts at right here and it goes like that. We're finding this area from 0 to about here. So these areas kind of cancel out, and then we're left with just the -1 that's still here. But if they cancel out, we don't know how far he's actually walking. We just know his starting and ending points. So to do it, we have to find, it's basically the integral from 0 to 3 pi over 2 of the absolute value of cosine of x. So we're just saying, you know, how far is he walking total instead of where his starting and ending points. So to do this, we have to actually split it up, and we have to find where this crosses from positive to negative territory. So we're going to have the integral from 0 to something, and the integral from something to 3 pi over 2. So where does cosine of x equal 0? Well, that happens at x equals pi over 2 and 3 pi over 2. But one of our boundaries is already 3 pi over 2, so we don't even need to worry about that. So we're taking the integral from 0 to pi over 2 and from pi over 2 to 3 pi over 2. Because at pi over 2, it goes from being positive area to negative area. And we need to calculate both if we need to know the total distance. So we take the integral from 0 to pi over 2 of cosine of x, and the integral from pi over 2 to 3 pi over 2 of cosine of x. But which one is positive and which one is negative? Well, if we plug in 0, we get a positive number. If we plug in this right here, we get a positive number for this. So that's positive. So this must be negative. What we're doing is we're going to get a negative value for this right here. So we're almost negating that negative number. Not a hashtag, it's a number. So we want to see the total distance, not having subtracted another distance from it, and that's why we do that. So I'm just going to integrate this really quick. So that's sine of x. So sine of pi over 2, 1 minus 0 equals 1. So we have 1 minus, and you're going to see this negation in a second, pi over 2, so it's sine x again. So we have -1 minus 1, which is -2. So 1 minus -2 is 1 plus 2 equals 3. And that's our value for this total distance. I hope that made some sense, because without that negative there, we would have just gotten 1 minus 2, which is negative 1. So that's the total distance he traveled as opposed to the net distance. Hope this made sense. Give it a like or a favorite, or I don't even know what else you can do anymore. But thanks for watching. Bye.